We're live on YouTube. Okay. So I welcome all of you all for the last lecture in this series. You all can hear me?
Yeah.
Yes.
Okay. So this is the last lecture in the series hosted by the Department of Physics, Somaya College of Science and Commerce. Before we go ahead, I would like to give you a virtual tour of the campus. Okay. Thank you very much. Shukumar, welcome to the lecture series. Now I would like to call upon Swapnil to introduce IAPT.
Good evening, everybody. My name is Swapnil Javkar, and I'm a member of the Indian Association of Physics Teachers, that is, along with KJ Somaya College, organizing the series of lectures. The IAPT is a national body of physics teachers across India. It was started sometime in the early 80s and has been involved with physics teaching and physics training for teachers and for students for the past so many years. We are the Mumbai chapter as part of working under the IPT national chapter, and we organize activities for student training through various camps and teacher training programs, both for degree and junior college. Okay, we are always looking for newer members, be it students or faculty, and so you can always contact Professor Shekhar or Professor Shetty. Professor Atul Modi is also there as part of today's discussion. They can always be contacted if you're interested in joining. With that, I'll let them start the program for today. So Shekhar, back to you. Shekhar, you're muted.
Thank you, Swapnil. I would like to also welcome Professor Tyagi, who has joined us for this lecture. Professor Tyagi, welcome. Now, I have the duty of introducing today's speaker.
Thank you very much, Shekhar.
Thank you,
Thanks.
sir. Thanks for
Thank you.
joining, sir.
Thank you.
Yeah.
Thank you.
So let me introduce today's speaker, Mr. Shiv Kumar. I've been associated with him for more than 20 years. Okay. Shiv Kumar started his journey at a very young age after completing 12th, joined Powertronics as a trainee in electronic circuit development. In the process, completed his diploma in electronics engineering. After that, uh, he went on to do his master's in physics. After that, looking at his work, he was elevated as a partner. He did lots of R&D in power electronics, very complex engineering work like developing manganese extraction furnace for TISCO, electrostatic precipitators for Godrej soaps to reduce sulfur emission during manufacturing process, won international awards in embedded systems. I developed and installed cycloconverters in oil rigs for Qatar Oil, and developed and installed solar systems for ONGC offshore platforms. Has developed and implemented low-cost LED lighting systems for the government of India. He was invited by the South Korean government as an Indian representative for the World Solar Conference meet. He has expertise in implementing solar rooftops, solar systems, rural electrification, and solar pump solutions. Currently, he is involved in developing the state-of-the-art electric buses in collaboration with Russian and British company, which is involved in developing Formula One cars. So, welcome Shiv Kumar. And I remember he used to say that as kids, when we used to play with toys, he used to play with wires and bulbs.
Yeah, that's true. That's true.
So he's in and out of electronics. You wake up him in the night, he will be able to give you a solution. So welcome, Shiv
Thank
Kumar, and you can start the lecture.
Yeah, it reminds me of my college days when we were together and doing our projects also. So I still remember that we used to do project for other students also. So it's a great pleasure once again connecting with you. And it's a pleasure that I've given you an opportunity to just see what we have done and just to what do you call this, throw some light on solar energy. Maybe you are well aware of all these things. So theory and all this, we are all experts, teachers. So we are a bit commercially minded people, business people. But here the thing is that if you want to stand your ground, then of course theory and practical things comes in the picture. And that's a very important thing. So I think you're all imparting all this education to the students. Definitely that will be very helpful for everybody in future. So today's I just directly wanted to jump into the topics. So I won't bore you with all theories since we are all experts in theory part, electrons and PN junction. So just brief on electronics to enhance the capacity of solar systems, how to control solar systems. I'll be briefing on that part. A small PPT I have prepared after Mr. Shekhar told me you have to give a lecture on solar energy. So I think we can start. Shekhar, is it right to start? Right?
Yeah, yes, start. You'll have to share the screen.
Fine. Yeah, I'll share it right now. I hope you're able to see.
Yeah.
Fine. This topic is today is harnessing of solar energy, photovoltaics. Since normally I deal in only electrical things and electronic things, so nothing to do with water heater system or any other thing associated with solar energy. So the topics we'll be covering today is basically solar panels, manufacturing process of solar panels, a brief description of solar cell and how it's made into panel, some small applications, then the basic thing required to enhance the capacity of a solar panel is the solar charge controller by which you can charge batteries and different type of chargers, working of chargers, and solar inverter of course is very crucial because we are we are doing it in a big scale throughout the country. Then solar inverters grid tied means without battery you can export the power generated from solar panel to the grid. Once again, this is a commercial entity, and of course smart management system, how to manage all these solar systems using latest softwares and embedded systems. So let us come to the basics of solar cell. You know, solar cells are basically it's a electrical device that converts light energy or energy falling on a surface, you know, into electricity, and this is called as photovoltaic effect, which has got a physical and chemical phenomenon. Once. Yeah. A solar cell is an electronic device which directly converts sunlight into electricity. Light shining on a solar cell produces both a current and voltage to generate electric power. This process requires firstly a material in which the absorption of light raises the electron to a higher energy state, and secondly the movement of higher energy electrons from solar cell to external circuit, like it can be a battery or it can be a electric load like electric bulb or LED bulbs, or it can be a fan or a motor. Anything which can run on DC power can be directly powered using solar cell. The electron thus generated dissipates into the load and it is returned back to the cell. A variety of materials and processes can potentially satisfy the requirement for the conversion. But in practice, nearly all photovoltaic energy conversion uses semiconductor material in the form of PN junctions. You're all very well aware of all these things. Solar cells are made from silicon balls, or you can call ingots. These are polycrystalline structures that have atomic structure of a single crystal. The mostly common used method for the creation of balls is known as the Czochralski method. During the process, a seed of crystal silicon is dipped into melted polycrystalline silicon. PV cells comes in a standard size of 156 by 156, which is approximately 6-inch long and 6-inch wide. A single solar cell produces only about around 0.5 to 0.6 volt. So I want to make it just give a idea on this one is that whatever we are describing right now is only about polycrystalline and monocrystalline silicon cells, and the other one is amorphous, or you can call it as vapor deposition, or you can call it as a thin film technology, you can say. But the advantage of this is that this is very compact. The silicon one is a very compact one. It occupies less space compared to your amorphous type of solar panels. The solar modules is actually basically a combination of solar cells, put it in series and parallel to get the desired voltage and current. So the cells are sandwiched between a glass plate and EVA sheet at the backside, which is vacuum sealed and framed for mechanical strength and fixing. The modules are available in standard 36, 72 or 60 cell configuration. I think that's a mistake here. 36 is not a V, actually it's 36 cells actually. 36 and 72 cells, depending on the application. So normally whenever you have a battery application, the solar cells are always either 36 or 72 cells. When there is no battery and you're going to utilize the power directly generated from solar panel, like in a grid-tied inverter, you go in for a 60 cell configuration. So 10 years ago, the solar panel with the size of nearly 2 meter by 1 meter, that is 2 square meter, could hardly generate around 250 watt power. But now the technology is enhanced using latest technology, whereby the power generated is in the order of around 330 watt per 2 square meter. So where the cell efficiency 10 years ago or 15 years ago, it was around 13 to 14%. Now it has come to around 19% efficiency. Secondly, the prices have crashed down like anything. Earlier, I still remember 15 years ago, the solar panel per watt used to cost around 135 to 145 rupees. but now hardly it's around 20 rupees per watt when you take it in a big scale, like a megawatt scale or something. So I'll just take you to a guided tour on how a solar modules are manufactured. A brief description. Solar panel that I have described already. Uh, you want to know the process in which this solar panels are. I'll just go through this one in a step-by-step manner. There are around 20-25 machines which involves around 18 steps to finally make a complete solar panel. So let us see how a solar panel is made. These steps or process are other than the quality check and the final assurance check. So the first, the cell which we get from the market, or you can say either it's European or Chinese market. In India, hardly one or two company manufacture cell, since the plant investment is very high, of the order of around 100 CR or in the vicinity of around 500 to 500 CR is required. So earlier one or two companies were there, but now they are closed. So all these things, cells, the basic form of solar panel is imported. So what we do is that we assemble the cells in series parallel connection to make a module. And for this, you require around 20-25 machines are required to make these modules. So the first process is that whenever you are using a volt cell, that is, suppose say the biggest capacity of a solar panel is 300 watt or 330 watt, then you don't cut the cell. So it's directly this cell cutting step is skipped. So only when you require of the lower like 75 watt, 50 watt, 30 watt, 150 watt, 200 watt panel, then the cell is cut to the exact size or requirement, which once again the software is there to guide us. So basically this is called as a laser scribbing machine or a cell cutting machine. So where laser is used to cut the cells, since these cells are just around 0.5 mm thickness, it's very brittle. If you handle it, it will break. So it has to be very carefully handled. So robotics are used to handle this cells. Secondly, the structure is so fine, it can damage with your finger also, it can get damaged. The cracks can happen. And this cutting can't be done with an axle blade or this thing. It has to be done through a laser process whereby minimum loss is there. So anything below 200 watt, the cell has to be cut to the appropriate size. Stringing process is nothing but a thing where all the cells are combined together. Combined means it's in put in series and parallel. They are soldered, you can say solder, or it's called as tabbing also, you can call it as tabbing. The upper sun facing side is negative, whereas the bottom white side is always positive in a solar panel or a solar cell. So normally a copper with tin plated copper is used to connect these panels in series. In fact, the top one is basically positive, and since series means it will go to the bottom of the other cell, and so on and so forth it happens. And you combine this thing to form a parallel one. So this is once again an automated steps. It's done by robotic, but if it's a very small panel in the range of around 3 watt, 5 watt, 15 watt, 20 watt, hand soldering is done, where low cost investment is required, where the output is approximately around 4 megawatt per annum. Then hand soldering is preferable, because this stringing and tabbing machine costs very high, in the order of around 20-30 lakh rupees. If you have robots and all this thing, it will touch around 1 to 2 CR. Then you got this solar glasses. So earlier we used to get these glasses from China or Europe, but now it is available in India. Borosil makes this glass in Gujarat. So this glass, it's basically a tempered glass. Means tempered means any impact won't crack the glass. Only the edges has to be taken care of. And then it is sandwiched between the ethylene vinyl acetate. That's called EVA sheet, encapsulation layer. In fact, the cell after stringing and tabbing is kept between this EVA sheet and the glass. Glass is the upper layer of a solar panel where the light falls. Then a physical examination is done. If all the cells are stacked properly, means deviation should not occur, thereby one cell encroaches with the other cell's area. So, and any proper soldering is done. So this a visual inspection is done before this is what you call sent to the vacuum impregnation plant. A taping is done. Taping is basically the soldering part. The cell should not fall down. A tape is used uh, to align this matrix so that it is adhered to the EVA sheet properly, so that the cells don't disengage or comes out or deviates from its required, what do you call this, assigned path. The connections are, once again, the soldering is done where all the cells which are in series is connected in parallel. So any excess this thing is removed using cutter, and alternate soldering is done manually. In fact, it's not done automatically, it's done manually. Now this insulate module connection is the next step, consists of insulating the connections by using a pack sheet EVA encapsulation. This process protects the module from any dust and moisture. So this, while in the process of manufacturing this thing, any dust can come from anywhere. Any of these plants are all air conditioned plants with the temperature maintained at 24 degrees centigrade, and moisture is less than 70% RH. So minimum dust should fall on the panel. This is taken care of by this plant. But then also in any eventuality, anything can happen. That's why this EVA sheet is put during after this tapping process. Once again, a mirror inspection is done, or what you call a visual inspection is done, whether everything is fine. Color mismatch means actually the panels cells are for different colors. It depends on the aging of the cell. Sometimes it might be light blue, sometimes it may be dark blue, or it can be darkish blue. Since the panel should look homogeneous or called equally, so a visual inspection is done whereby the cells are matched basically. Apart from the voltage matching and the current matching, the cells are matched according to the appearance also, so that the uniformity of the panel is maintained. Now this is called as an electroluminescent test. In the real testing, the modules made so far, it is a testing process where the module is kind of scanned in an EL machine, electroluminescence machine. We can easily spot any dead or power source. In fact, when this current is flown, when a light falls on this one, a voltage is produced. If it is below a certain level, then there's a problem with the solar cell. So this is the last stage where you can do a correction. Once it goes to the vacuum impregnation, the cells can't be repaired or any error can't be fixed. Whereas this is the last process before it can't be retrieved. So this where any error occurs, it can be rectified. The module is basically laminated. Laminated means it is vacuum impregnated, means the sandwich part, the cell is sandwiched between the EVA sheet and the glass with a gum or a what you call particular chemical is used to bond this together, and it is heated at a temperature of around 140 degrees centigrade for approximately 20 minutes. After the lamination, the modules are left outside the vacuum plant to cool it down to come to the room temperature. If it's directly exposed to room temperature or it's cooled on, then the cracks will appear on the cells. Glass, nothing will happen to the glass, but the cells can crack up due to sudden variation in temperature. Trimming the black sheet is nothing but once the encapsulation is done, then certain EV sheets will come out due to the pressure applied, and the vacuum actually sucks out all the bubbles of air, moisture, everything is removed in that process of insulation. So this year the excess EV sheet is cut using ordinary knives. So this is very crucial, otherwise this won't fit into the structure, what you call the frames basically. This is a frame cutting machine. It's just like an ordinary axe bed, but here it's done in what you call it's a automated one. Once again, it's a CNC controlled one. It's controlled by a computer. So at what angle the frames have to cut is determined. It is programmed, and this cuts the frame exactly to the requirement, so that whatever solar panels are manufactured, the sizes are maintained, because all these panels are all of international standard. There's no deviation. The deviation can be of the order of 1 mm or 2 mm, but nothing can exceed this limit. Otherwise, it will become unstandard. So this precise thing has to be maintained. So the cutting is very crucial. This frame cutting is very crucial to maintain the consistency of the panel size. Frame punching is nothing but, once again, this is the international standard whereby they are fixing holes. The panel has to be mounted in a panel mounting structure. Once again, the mounting structures are manufactured by some other OEM company, or it can be exported where other countries can manufacture this mounting structure. But the holes are of international standard where no deviation is allowed. So for each panel, sizes are there. 2 by 1 meter will have a different size of holes. The whole distance between the holes, the interspacing has to be maintained very precisely. In the event of panel replacement by some other company manufacturer's panel, you can directly fit it without bothering of how to fit this panel when the hole sizes change or the location of the hole changes. So once again, this has to be very precisely done. So once again, this can be hand done or it can be done using CNC machine. Now, this sealant filling is a very important thing, since normally these panels are exposed to rainwater, other this thing. So where this panels has to be solar, whatever frame we have made, has to hold the glass solar panel properly. So the sealants are used to hold that thing in place, and secondly, fix the panel without any problem. So any amount of pressure applied, any amount of force applied won't part this way. The frames won't open up or the glass falling down. It won't happen. So these are all very high quality sealants used. It's not like our sealant which we use it in our windows or which is available, commonly available in the hardware store. But these are specially designed sealants, specially made for solar applications, where even a temperature of around 150, 160, 200 degree also won't have impact on such things. Now, junction box is very crucial, where all the series parallel connection of the cells are terminated, and it's in the back of the panel. And these junction boxes are all IP66 grade or IP65 grade, where not even a moisture could go inside, because the termination is very crucial for the efficiency of the panel, where all the fasteners, the screws, the nuts, everything is kept inside the box, where external connection to the panel is done. So this is once again a very crucial thing. Once again, it is pasted to the back side of the EVA sheet or the back side of the panel, the right side of the panel. So here the durability comes into picture, where the longevity of the panel depends on how your junction boxes are mounted, how it is fixed. It should not snap off. Once it snap off, then the interconnecting string, what do you call this? It's a small piece of putty, you call it as a string, that can snap up, due to the weight of the cable. So this junction box, there's no fixing holes or nut bolts can't be used, fasteners can't be used. So once again, the sealant and the thing comes in the picture, which holds the box properly. Even if you apply a pressure of around 50 kg on this junction box, this won't snap up. Then these modules are clean so that a maximum efficiency is achieved. A light falling on a panel. During this process of manufacturing, always the foreign particles, extra sealants can fall on the surface of the panel. So with isopropyl alcohol, these panels are clean and all the dust and everything is removed before packing. And once this process is over, this goes to a module testing system, whereby the modules are tested for its current voltage, power, etc. A report is generated for each module, and this is pasted with the panel, and it is given to the end user. Finally, the module is sent to QC lab, where it is tested for insulation resistance. Once again, a 3000 volt DC is passed through it for a minute. That is the voltage between the structure of the panel and the terminal. That is the input and output terminal. That is the input terminal. That's the, sorry, basically the positive negative terminal of the panel is shorted, and a high voltage is applied between this terminal and the structure of the panel. So at 3000 volt DC is applied for a minute, and no flashing to take place. The current should not exceed 1 milliampere. And once again, here is a destructive test. If it exceeds 1 minute, always insulation breakdown can occur. So once again, it is done through a controlled tester, whereby the timer is set for 1 minute. If it exceeds, then the panel can get irreversibly damaged. So we have to take care of that one. And finally, the modules are packed because the manufactured area is very far off from because all these panels are used in remote areas throughout the country or exported, where the packing is very crucial. Otherwise, the panel can get damaged. So once again, a very thorough packing is required, whereby any large mechanical impact also won't damage the panel. So I think this covers the manufacturing process. So next, we will go into the characteristics of a solar panel. So I think since you're all in the academic field, so you might have all gone through this process of voltage and current characteristics of a solar panel. This is a very crucial thing. A solar panel basically behaves like a constant current source, but actually the power available at maximum, the power is available at that time. It's very crucial that the voltage and the current is what we require. And this happens only when the peak sunshine occurs. So normally in a country like India, where temperature variations are very high, this VMP, as you can see the green line, the current line, blue line, actually varies. The knee, knee means where I have marked as VMP, varies with temperature. So not whatever test we do, it's a standard uh, test we do at 25 degrees centigrade. But normally when you go to actual site conditions where the temperature of the panel can exceed 75 degree to 80 degree, in certain African countries, it can even touch around 80 to 85 degrees centigrade. Since this is basically, it absorbs the light and it is converted into heat energy. So what everybody has most of the people have got a misconception that more the light falls on the panel, more power is generated. But this is basically a misnomer. Actually, you see, more power can be generated in European countries compared to that in African country, because as the panel is cool, it can generate more power. The knee will shift to the upper side, whereas at a very high temperature, the knee will come down. The MPP and the VMP can come down as the temperature increases. In standard test condition, fine. Whatever you see, this graph is standard test condition, STC at 25 degrees. But normally in Bombay climate, it can touch around 50 degrees, 55 degrees temperature centigrade. Whereas in Rajasthan, it can touch around 75, 80 degrees centigrade. In Kashmir, of course, it's around something like around 45 to 50 degrees centigrade. So in our practical experience, we've seen that maximum power we generated is in Kashmir, whereas in Rajasthan, we get the least power. So more panels are required. Basically, that will increase the cost. So that's a trade-off in a solar panel. So no cooling method has been found till now to cool the panels. Maybe some water circulating things have been done, developed by some European countries, but practical things are there. Now, let us go to a basic thing, solar charge control, which, as I told you, we are manufacturers of solar charge controllers, solar inverters, and all electronics and balance of systems required for a solar power plants we manufacture, apart from the solar panels. So this basically, this is the bridge between the load and the panel. As you can see that solar panels can't be directly connected to a load because the current is unregulated and the voltage is unregulated. So you might be thinking that average sunshine is 5 hours. This 5 hours we can use the power, but it's not the case. It can damage certain equipments, voltage sensitive equipments where input voltage has to be regulated. So to control this thing, we have got a thing called as a solar charge controller. Basically, it comes in a basic form called as an on-off charge controller. Then you got pulse width modulated charge controller and the maximum power point tracking charge controllers. We'll just small presentation on type of charge controllers. So this is the manual on-off charge controller. It is a basic form of solar charge controller. See, represented by a switch. Actually, what we are doing with the controlling device is basically a switch. What we do is it is connected to a battery. But the problem, as you can see from the characteristics of a solar panel, this panel behaves like a constant current source. So only under short circuit condition, the current can increase to around 1.25 times the actual current which the panel can deliver at maximum power. So this switch is used to control the current flowing into the battery. Basically, what we do here is a manual switch is nothing but a observe and control. So what we do is that we take a multimeter and put it across the battery and connect a solar panel in series with a switch. The switch is closed. We monitor the voltage of the battery. As you know, all these batteries are all voltage sensitive. A lead-acid battery can absorb only up to certain voltage. If it goes above this thing, in a lead-acid battery, the acid gets boiled up. It can damage the plate. Evaporation of electrolyte takes place, and it can damage the battery permanently. And secondly, you have got other batteries, like tubular batteries. Then you got nickel cadmium batteries, which are all once again sensitive to voltage. And latest is the lithium-ion batteries and lithium ferrophosphate batteries. Once again, here a controlling device is absolutely essential, since the solar panel can directly charge the battery, and it will damage the battery. So what we do in this example is that if we give input voltage from solar panel, it is connected to a battery through a switch. Now we monitor the voltage of the battery. We know the battery manufacturer specified for a lead-acid battery, for example, 12-volt battery, the voltage, maximum voltage it can touch is around 14 volt or 14.5 volt at around 50 degrees centigrade. So as soon as it touches 14 volt or 14.5, switch off the switch is thrown open. That way disconnecting the solar panel. But this can't be done daily. Somebody has to sit with a panel and a multimeter and a battery. So something we require, some automatic thing. So we have got a simple circuit here, on-off battery charger, where instead of using our eyes to monitor the voltage, to read the voltage of a battery using a multimeter, we are using a voltage comparator. A standard reference is given, and a feedback from the battery is given to the comparator. So whenever the battery voltage exceeds the reference voltage, or in this particular case 14 volt or 14.5 volt, depending on the temperature, the switch is switched on or off. And there is a hysteresis also in this particular comparator, whereby when the battery voltage goes below 12 volt, the switch is operated, switched on, and when it goes above 14 volt, it is switched off. Here you can see the blocker diode is used, a D1, because normally what happens whenever a solar panel is connected to a battery, there is always a possibility that during night time, if there is no load, the battery gets discharged to the solar panel, because the solar panel impedance is low, but then say discharge takes place, and there again it can damage the panel also. You require a blocker diode. In all solar equipment, you can see whenever a solar panel is connected to equipment, a blocker diode is very essential, because this will not only protect the battery getting discharged, it can be done for paralleling of panels, whereby one panel doesn't get discharged to the other panel. So this is very crucial. And here what we have used is a simple on-off charger. Ignore the D1, D2, L1. This is a tank circuit, so it's not required in this particular application. But certainly, if you require a PWM, you require all these things. So here we are used, instead of switch, we have used a MOSFET or a transistor can be used, which can be controlled using an operational amplifier or a comparator. So this can be switched on and off. When it goes above 14, it's switched off. When it goes to 12, it is switched on. So once again, it's an automatic one. This is a very low cost. It can carry a current of approximately around 5 to 10 ampere without any much of a problem. But only one drawback is that the battery, lead-acid battery can get charged only up to 70%. So you can't charge the battery because the consolidation of the battery doesn't take place. So what we do is that whatever power is available from the panel is passed on to the battery, but when the consolidation takes place, at that time we disconnect the battery, thereby depriving the battery of the excess charge which is required to consolidate the battery formation or cell formation. So here to overcome that one, we are going to think called as a PWM charger or pulse width modulated chargers. Once again, this is very highly efficient charger where the efficiency can touch up to around 98% electrical efficiency, and the battery can be charged up to 100%, 70%. Normally what we do is that whenever you connect a panel to a PWM switch, there's a microcontroller which generates the PWM, that's a feedback. and you got the RTCT depending on the type of frequency required to charge a battery. And there's a tank circuit to filter the output so that no ripple goes into the battery, because once again the ripple can be determined to the life of the battery. The plate solidification takes place, thereby rendering the battery ineffective over a period of time, maybe a year or 2 years to replace the battery. To avoid that one, what we do is that we filter out the ripples. A pure DC is given, just like in telecom application. This is used. Here, what happens, whenever you connect, the feedback comes, and the controller thinks that the battery is stored of energy, and it fully drives the transistor 100% duty cycle, whereby the battery gets charged to whatever power is available from the panel. Then the voltage increases once it goes to the set level, and this process is called as a boost charging. Once it reaches a level determined by the manufacturer of the battery, the currents, the voltage is maintained at that level, and the PWM comes into picture, whereby it sees that the output voltage is maintained and the current starts falling. The current start or drooping takes place. When it reaches 25% start charge state, then the voltage level is shifted from the boost level to the float level or trickle level. Trickle level is when you use it in an offline application. It's called trickle, where the battery is always in standby mode. Whereas in a float application, where the load is always connected to the battery, there you give a trickle charge. Trickle charge is nothing but to compensate for the losses, internal losses. That's the internal resistance in a battery, whereby internal chemical reaction, internal resistance is nothing but a chemical reaction takes place inside the battery if you keep it alone, and a self-discharge takes place. Normally, it is seen that it's 1000 the capacity of a battery. In order to overcome that one, we give a compensatory charge, basically called as a trickle charge. And this circuit, it's completely automatic. It sees with that the battery is boost charger, then it is consolidated charging takes place, then the final trickle charging takes place, where 100% care is taken care of the battery. Absolutely, the battery, even temperature compensation can be used, because not only the battery charging process is a very tedious one, it's a messy one, acids are involved. But problem is the temperature can be determined to do the life of a battery, where temperature compensation is very, very essential. So whenever there's a higher temperature, if you pass more current, the evaporation takes place. So you have to reduce the current at higher temperature, whereas at a colder temperature, you can pass more current and effectively charge the battery. So the processor basically, it senses the temperature. There's an algorithm inside the processor which determines what type of charging is required, how much current is required, how much voltage has to be set. Basically, the current is not controlled. Basically, the voltage is very much controlled here. The 14 volt, which I told, is basically for standard test condition of 25 degrees centigrade. So this 14 voltage, whatever we kept it as boost voltage, can go up to 14.5 also at around 10 degrees centigrade, can come down to 13.5 at around 45 degrees centigrade. So the battery temperature is very crucial, and this particular PWM charger has got all the ingredients to safeguard the life of a battery, so that the battery longevity is increased. Battery can last, battery can last up to 5 to 6 years or 7 years. In some cases, we have seen around 30% of the battery can last up to 8 years also. Now, the only drawback with this particular circuit is that the solar panel utilization is very less in this particular case. Since normally you're seen, as I shown in the characteristics, whereby, for example, you have 100-watt panel, the VMP is approximately 16.6 volt at 25 degrees centigrade, and the current which is going to give is approximately something like of the order of around 6 ampere. So 16.6 multiplied by 6 will give you approximately around 100 watt. But once you connect it to such chargers like an on-off or a PWM charger, due to the impedance of the low impedance of the battery and the high impedance of the solar panel voltage is dragged to that of the battery voltage. That is a 16.6 volt solar panel voltage is brought down to the battery voltage level, which can't exceed 14 volt. So effectively, you see that the panel voltage comes down to around approximately, if it's in the initial state of charge of the battery from 12 volt, it starts charging. The panel voltage from 16.6 comes down to around 12 volt. So 12 multiplied by 6 is once again 72 watt. So what we are doing is here is that you are effectively using only 72 watt of the power of the panel in the initial state. Then the wattage increases as the battery charging takes place. So, so this once again, this is not a proper charger, but this is very effective when you don't have to consider, since you've got more panels, you don't have to worry about the losses as such. So, and this is mid-range. The prices are always mid-range and basically used in low power equipments, telecom equipments, where here the noises are very less compared to that in the MBPT charger. And secondly, in low power inverters, like anything less than 10 kilowatt, PWM type of chargers are used, whereas the on-off chargers are used anything less than 300 watt. So next we'll go a thing called as MBPT charge pump. MBPT means maximum power point tracking. So apart from this output voltage and current, we monitor the input voltage and current. Basically, this is the product of voltage and current. That is the power the controller senses. And here we use an algorithm called the Perturb algorithm, whereby the correction speed is so high that within 1 millisecond, the reading is taken and it is compared to the previous reading. Then this output PWM is controlled, whether it has to increase or decrease, whether more current is required or less current. If you see that when you pass more current, then the voltage panel voltage will come down. To increase the voltage, to increase the efficiency, what we do is that we use the Perturb algorithm, whereby on off, on off, on off is done in a particular grade. So here we had seen that this controller sees that the panel is used in the VMP range. That is the voltage at maximum power, or the maximum power of the panel is utilized. In the earlier PWM case, where the panel voltage is tracked down to the battery voltage, in this case doesn't happen. So it is always maintained at VMP or MPP, maximum power, by this complex algorithm, and so that a 100 watt panel will deliver 100 watt power. And once again, the efficiency of this particular circuit is as good as the PWM circuit, except it was got more monitoring point, more sensing points are there, more controlling points are there, more complex drive circuits are required, losses are minimum, and this is very crucial for anything high capacity inverters, where anything above 10 kilowatt, such types are chargers are mandated. It's mandatory according to Ministry of New and Renewable Energy. MBPT is a must in all the systems which has got a power of exceeding 10 kilowatt. So as you can see, these batteries can be charged in various ways, and I will just typically discuss regarding lead acid batteries, whereas now the trend is basically lithium-ion batteries and lithium ferrophosphate batteries. So normally this lead acid battery, the single cell is always 2 volt, whereas in a lithium ion it's 3.7 volt, whereas the lithium ferrophosphate is 3.2 volt. And once again, here the temperature is crucial, so temperature sensing is required. So we had seen through our practical experience that the on-off charger is very good for a lithium-ion battery and a lithium ferrophosphate battery, whereas the PWM and MBPT chargers are basically used for high grade, high power lead acid batteries. Next, we come to the solar inverters, basically called as power conditioning unit or PCU. So here it's actually a combination of solar charge controller, which we discussed earlier, and a DC to AC converter called as an inverter. So typical schematic given here, the input voltage from the panel is given to a solar charge controller. It can either be a PWM or a MBPT, depending on the type of load is there. Like anything less than its PWM, anything less than 10 kilowatts PWM, anything about 10 kilowatts MBPT. And this basically charges the battery. And all this scheme, it's basically off-grid. Off-grid means normally in rural electrification or village electrification, we have done lots of things here in this thing, where During the daytime, the batteries are charged, and during nighttime or the evening, the batteries are powering the load. The load can either be tube lights, fans used in villages. So the villages are not short of power during nighttime. So here once again, the solar charge control is very crucial because each and every wattage has to be extracted from the panel without much loss. So once again, the commercial things comes into picture. So why the government has mandated anything less than 10 kilowatt PWM is the cost, because all this village electrification is all below 10 kilowatt. So normally we go in for a PWM. If the price permits, then we go in for MBPT. And the inverter is basically, it's basically a DC to AC converters. The inverter comes in various outputs, either it's a square wave or a quasi square wave. Quasi square wave can be called as a triangular waveform, and then you got a sinusoidal waveform using digital signal processors, which sees that the output is precisely 50 hertz and has got a crest factor of not exceeding 1.414, and it has got an excellent uh, power factor of a unity power factor we give normally. So whatever we mentioned in terms of VA is always equal to that of a watt also. And this can drive various loads, inductive loads or resistive loads, capacitive loads without any deviation in the waveform. Basically, deviation is basically termed in terms of total harmonic distortion. So the permissible level of distortion should not exceed 3% for any given equipment. And this is the tolerable one, 3%, and which normally in any system, in our case, it's less than 1%. So here it can be either a 12 volt system or a 24 volt system or a 48 volt system or a 96, 120, 240 volt, depends on the capacity of the inverter. And the charge controller charges this battery. Battery powers the inverter. This inverter is once again basically it's not a run-of-the-mill push-pull inverter. A H-bridge or a X-bridge, we use it for three-phase. So the output of this is fed to a transformer for isolation purpose. This output voltage is stepped up or stepped down, and you get a 230 volt output. There's a feedback circuit is that a transformer is used. In this case, its voltage feedback is TR2, and a current feedback is basically for CT2. The output current is monitored and the voltage is monitored. The output voltage is maintained at 230 volt plus minus 1%, and the current is monitored so that overload doesn't occur and shut off the plant. So it typically happens that any accidental overload can take place. To avoid that one, you require this load limiter or a CT is required to monitor the current, and you've got the input MOVs or metal oxide varistors or SPDs called as surge protection devices to see to it that any lightning falling on a solar panel doesn't damage the electronics. It happens in villages or any remote area. Maybe in city it doesn't happen much since you've got high-rise buildings where the lighting doesn't directly strike on a solar panel. But in villages, since the spread is very long and the solar panels are exposed to nature, lightning can definitely fall on solar panel. So we provide such protection so that the controllers and the inverters doesn't get damaged. The solar panel, of course, it is protected, and but the crucial, what you call fragile thing is the inverters and the controllers. So you require such thing. And apart from this, in certain cases, certain villages, grids are available only up to certain time. So automatic changeover mechanism we provide whenever grid is available and the grid power is used. When grid is not available at the time, the solar is taken as priority, and when solar is not available, your battery is taken as the next one to power the load. So here the priority is basically grid, solar, and battery. In a typical off-grid, it is always solar and then battery comes into picture. So here once again we use a digital signal processor to generate the sine wave. Here's basically a quadrant. This is a single phase system. It's a quadrant drive is required. There are 4 arms, basically called as 1, 2, 3, 4 arms of an inverter. and the center arms are shorted and given to a transformer, and the upper and the bottom one is the where the DC bus is connected. So the output is a basically called as a weighted sine wave, or you can call it as pulse width sine wave pulse width modulated SPWM. So this as a transformer, the transformer output is stepped up and filtered. Basically, the leakage inductance of a transformer along with capacitor C2, it forms a tank circuit, and this integrates the pulses of the output and generate a smooth sine wave with minimum distortion. So I think this will take care of our single phase. Let us go to the next thing called as a three-phase system. This three-phase is basically, once again, it is same identical to that of a single phase, which I explained to you earlier. But here, instead of single phase transformer and a single phase bridge, we use a hex bridge, and three-phase transformers are used. And the output is basically 415 volt, 50 hertz, and once again the phases, the output phases are 120 degree out of phase, all the three outputs. And you got once again drive circuit, the CTs are there. Like in this particular case, we use the output voltage, sensing the output voltage. It's combined, given to a controller. Once again, a DSP is used to monitor the output voltage current, and where crest factor is very crucial in three-phase systems, because if we face and phase imbalance is also taken care of. Normally, it's seen that always phase balancing is a bit notorious thing which can damage the inverter. Phase imbalance is basically the thing is that where one phase is loaded, the other phase partial loading takes place, or there's no load connected, whereby the entire system comes into strain, and we monitor such things and we immediately shut it down, basically called as a phase shutdown. So there's the people responsible for installing such systems as to ensure that the balancing of loads are equally on each phase. There should be no imbalance. Imbalance takes place, it can work up to 20%, 30%, but anything above that will shut it off. And basically, we have got once again the input is a MBPT charge controller. Battery is connected same way, but here more complex things are there, where more the output waveform generation, the monitoring things, the temperature compensation, even the transformer temperature is, since it's basically anything about 10 kilowatt, we take everything into consideration. The temperature of the transformer, the winding temperature, the cable temperature, the ambient temperature, the heatsink temperature, the device temperatures, everything is taken care. And all this information of temperature is fed to a controller, which is already preset. If anything exceeds, it is flagged off, and thereby the output correction takes place either through pulse width modulation or shutdown. The contactors are open, load is disconnected, or if the battery, once again, if the battery exceeds certain limit, sometimes the charger can fail, whereby short can take place, whereby the solar panel can charge the battery exceeding the input limit of a inverter. So here also we monitor the battery voltage and it shuts off the system. In case of the battery going low, you can't discharge the battery to a certain level, whereby it's not recoverable. It's irreversible damage can occur to the battery, whereby we monitor the input voltage and it shuts off the battery in the event it falls below a certain level. It's called a low cutoff, and if it exceeds certain thing, it's called a high cutoff. So the inverter, maximum protection is given to the inverter because it's a very costly item, where we see to it that the input is protected either through SPDs, MOVs, and apart from that, voltage sensing of the battery. High voltage, low voltage can be damage the inverters. And secondly, the output voltage, once again, a short circuit or a overload can once again damage the system. So once again, we have to measure and sense this thing, a overload within a fraction of a second. Maybe in this particular case, it's around 20 to 30 milliseconds has to be sensed. Because normally the waveforms are compared with the current waveform and the voltage waveform, distortion, load, in particular terms of power factor. So any deviation occurs will shut off the system, and flagging off and giving an indication that such thing has occurred. And in this things, we have got the thing called as a data logging facility or a remote monitoring features are there, whereby the output voltage, output current, loads, the input current from the solar panel, battery voltage, battery current, charging current, discharging current, all these things are data logged. There's a data logger inside the system which monitors and stores it in. Whenever you want the information for a particular day, it is all got date time stamp. You can retrieve this information from this device, or it can be relayed through some smart management system. It can be remotely monitored. Somewhere in USA, you can sit and monitor the voltage current. You can switch it on and off remotely through IP or through what do you call this mobile communication. So this is basically once again off-grid system where battery is very crucial. So now next one which we are going to discuss is basically system where it's basically once again a simple same identical to that of what we discussed previously. There's no change at all except that there's no battery in this particular thing. In fact, in the earlier case, the battery acts like a buffer, because due to its low impedance, any solar voltage variation is taken care of the battery. You can see the cloud coming, blocking the sunlight falling on the panel. Suddenly, there's a dip in the power from the solar panel. If you connect directly a solar panel to a load, that once again the load will switch off if it's voltage sensitive, or if the sunshine comes or bright happens at the time, it can damage the load. So in order to avoid that one, we use a battery whereby it acts like a low impedance source and it absorbs the variation in solar panel. Whereas in a grid-tied inverter, such things are not there. So once again, here we use a input MBPT system, which once again goes to X inverter. Transformers may be there or maybe not there. Since normally, as I discussed in the battery system, you don't exit 360 volt DC. Basically, batteries, you can stack it up, put it in series, can't exit 360 volt DC. Anything about 360 volt DC can damage the insulation of the battery, that the container flashing takes place. So, but whereas no such restrictions are in this particular grid-tied inverters, where the inverter input voltage can exit 640 volt DC to 1000 volt DC. Once again, it goes to a MBPT. You can't see charger here, MBPT controller, and which regulates and maximum extracts the power from the panel. One goes to the X bridge, which can directly drive an external transformer, or it can give a 415 volt AC output. And there's once again, here there's no load directly connected, but it is given to the grid. Grid is basically your MSCB supply or a BSC supplies you. That is called a grid. You can directly sync with the grid. The output of this inverter is directly fed to the grid. It can be isolated using an isolation transformer. It can be stepped up using an isolation transformer. It can be stepped down if it's a high voltage to the required grid voltage standards. So what it does is that basically in a grid-tied inverter, the voltage and the current and the phase of the grid is monitored by the controller. Here, once again, we use a DSP since it has to process so many signals simultaneously. A microcontroller won't be able to do such things. It can do one at a time, but here simultaneous processing of information is done. And where synchronization is done, once the synchronization takes, whether the voltage, the current, and the waveform and the frequency is matched, then the system is connected to the grid. And it is always seen to it that the voltage of the inverter is slightly higher than that of the grid, so that the current flows from the inverter to the grid. So it's not the other way around. It flows from the inverter to the grid, and currents are monitored. And secondly, whatever power is generated can be fed directly to the grid. So nowadays, maybe for the last 6 or 7 years, we have got a thing called as a reverse metering, or called as a net metering. But what happens is that when you don't have inverter, such inverters, the power you consume is the one where the meter rotates in one direction. And in this particular thing, when you generate excess power and you feed it to the grid, the meter rotates in the reverse direction. That is supposed to say, for instance, if you don't connect an inverter, you're consuming approximately 100 units per day or 1000 units per day. If you connect a 10 kilowatt three-phase system to your grid system and approximately it can generate around 50 units per day. You will see to it that the end of the day, your power consumption will be only 50. It won't be 100 as in earlier case. So if it generates more power in cases like Sunday, where those you don't consume any power, whatever power is generated is directly fed to the grid, or the electricity board consumes the power, whereby you get a rebate on your electricity bill. Or if you commercially exploit such things, then like in a megawatt power scale, where you what is called as a solar farming, where the power is generated is fed to the grid. You sign a power purchase agreement with the government or the distribution company, whereby remittance is made to you. The remittance earlier, 10 years ago, it is around something like around 18 rupees per watt unit generated. But now it has come down to around 2.8 rupees or 2.9 rupees per watt per unit generated. Is in parity with that of grid supply. So grid, what you call on-grid systems or megawatt scales basically are done by government agencies, because it's not so lucrative nowadays for any investor to invest such huge sums of amount. Like in a 1 megawatt, the cost involved in, or the capital cost is approximately something like 3.5 to 4 crore, where earlier it was around 16 to 15 to 16 crore rupees. But the returns are very less. Earlier, the break-even period or ROI was around 6 years, but now it is around something like around 12 to 13 years. So, so that's another topic, regarding commercial usage of solar energy. So this covers our grid-tied inverter. As I explained to you, there are different types of inverters. One is your off-grid, the other one is the on-grid system. And then on-grid also, once again, is split it up into uh, what do you call this, single phase and the three phase. And other one is called, the one which I'm going to discuss is called as the hybrid inverter. A hybrid inverter is a simple thing that in an on-grid system, which I explained to you earlier, it can't be stored. The energy during the day which solar produces has to be utilized by the grid or by the load, or if there's no utilization, the power generator is going to go down the drain or it's wasted. So a hybrid inverter takes care of it. It's basically amalgamation of combination of off-grid system and on-grid system, where battery is used during daytime or whenever excess solar is generated, where your grid doesn't demand that power. You can divert this power to a battery, store the energy in a battery, and it can feed the grid or it can power your load. So this is the new generation type of inverters. It's once again a very complex one, whereby it takes care of the charging. There are two parts once again. Your battery charging is there, and you've got a grid tied inverter. So it's a combination of both these things. But once again, here the output useful voltage is once again going to be either order of around 415 volt or 230 volt single phase. So transformer isolation is required since you're going to use it for your domestic application. So this covers our inverter chapter. And next one is your, basically this is basically off-grid inverter image which we developed, which we use in all our applications and offshore applications. In platforms we use it, oil rig platforms we use it, in village electrification we use it, and all these enclosures are IP65 protected from environment, water ingress, dust ingress. Then coming to the last topic called as solar management system. Here once again, in as I explained to you earlier, in our grid-tied inverters, the life of a power plant depends on how you monitor the system generated by the solar panel, where downtime should be less. That is, the failure rate should be less, because each and every minute counts. Whatever power you're generating is directly converted into money. So you have to utilize, basically all these farms and solar farms are basically nothing but a commercial entity, where even a minute of failure of the system will push back your ROI. In order to avoid that one, we developed a thing called a smart solar management system, whereby each and every solar panels are monitored individually, its temperatures are monitored, its performance are monitored, its graph should simply follow what is the ideal graph, no deviation is permitted. So its voltage, current, power generated is monitored continuously. Every second, every minute is monitored. Any deviation, that particular panel or the particular segment or the particular strings are flagged. Immediately it is notified to the user or the operators, thereby corrective actions are taken. And basically, this monitoring system, basically a supervisory control and data acquisition, we call it SCADA. It has got sensors and the communication sensors are basically, you got a rain sensor, then you got a irradiation sensor, and then temperature sensors are there, and then wind sensor, wind velocity sensors are there, because all these structures where the panels are mounted can withstand up to a certain level. All these structures which we do can withstand a wind velocity of around 150 kilometer per hour. Anything exceed can be disastrous. A warning has to be given, whereby the plants are shut off. Even in operation, if such comes, it can damage the inverters also. Apart from the physical damage occurring to the panel, it can damage the inverters also. And the mode of communication is basically either through this VHF, that is point to point communication takes place, or it can be once again internet protocol, that is whatever, it's through communicated through internet. It can be monitored from anywhere in the world, or through GPRS or GSM networks are there. Once again, remote monitoring is there. Suppose my plant is somewhere in Tamil Nadu, I am sitting in Delhi, so all the information are available in the fingertip. Any deviation, anything is notified immediately, either through a mobile app or through my computer. A SMS sent to my mobile. It indicates the system has failed, particular string has failed, particular two strings have failed, the plant is down, the inverter has failed, the IGBTs are blown off. So whatever information, uh, there are nearly around hundreds of points where all these things are monitored for a particular power plant. All these things are relayed real time to the user, whereby corrective actions are done. Either if you have a contractor to maintain this thing, the information is directly given to him, whereby he sends his person or a on-site persons are there who is notified, immediately corrective actions are take place. If panel gets damaged, physical damage takes place, then he can replace it by spare panels. And this downturn is reduced to a minimum. So all these parameters, whatever we monitor, are stored in a central server, and it can be accessed anytime. Basically, any commercial entity requires this energy audit. You have to government, give it to the government, and so many things are there. So the smart management system is very crucial for any solar power plant. Even in a basic street light applications, solar management system is required. Suppose you got a standalone solar street light, a battery simply operates through a circuit or charge controller with a load controller, a LED light. So the panel can get covered up with dust or pigeon droppings, which can generate less power, whereby the backup duration normally typically just to on extends up to 12 hours. If it comes down to 8 hours, 6 hours, immediately SMS sent to the user, whereby he knows that something is problematic. Either the battery has got damaged or the panel is not sufficiently charging the battery, whereby corrective action is taken. He can send his person to clean the panel. So it can happen in village electrification also, because the villagers are not technically qualified to service such things. And our technical persons can't go to village and can't be stationed there permanently, because all these systems are 2 kilowatt, 3 kilowatt, 5 kilowatt, 10 kilowatt. So you can't have a permanent representation. These are all subsidized things, subsidized by the government, and where they won't be able to give service, on-site service immediately. So this relays information immediately on any problem occurring, and a service technician is sent to the site within 24 to 48 hours, and the rectification is done. So here once again, this smart solar management system comes into picture. So as you see, this entire system, right from solar cell manufacturing to solar panel manufacturing to inverters, solar charge controllers, smart management system, which is the overall thing, is one huge package. And this is very crucial for any solar power plant. If anything, one thing is missing, then the thing is that this system won't work properly. So all this thing has to be taken together, then you will get a very good end result. So I think I have nearly completed the presentation. Shekhar, hello.
Yeah. Uh, Thank you, Shivkumar. I think we have few questions,
Yeah, yeah.
so we'll take those questions. Pallavi madam,
Ye-
can you please take on the question answer session?
yes, sir. Thank you. Thank you, sir, for such a nice talk. Now, there are few questions from our participants. First one, what is the characteristics we should look
Yeah.
into while buying the complete set of solar panel for domestic purpose?
Okay, fine, fine. I got it. I got it. So normally the thing is that first you have to determine the load. Actually, the thing is that normally everybody, I had seen that since we have got a experience in this field that they purchase uh, to the maximum. What is that? Unnecessary things are required. Means you have to basically tone down the thing. First you have to make a list of the loads you are going to run during emergency. It's basically for off-grid application where like power outage is there, where a minimum power is minimum things has to be light up. Like fans. You got in a house around 10 fans and 10 tube lights. So you have to narrow down. I will require only five, and only five fans will be run during power outage. So first you have to find the load you're going to connect, and secondly is the duration of the backup you require. Suppose, say for instance, you're putting a 1 kilowatt system, and you see to it that the power failures normally occur during the evening time. It is between 6 o'clock to 9 o'clock, so 3 hours is that. So I want a backup of 3 hours exactly. And secondly, so no solar days are there. No solar means you have got a cloudy day where only 20% of the battery will get charged, or when solar power generation will be only 20%. So you require a battery autonomy. That is in case your battery is not getting charged. So how you're going to get a backup? So you have to reserve that thing. The energy is stored in the battery. So for instead of you require 3 hours, then the size of the battery is very crucial where autonomy comes into picture. So you have to say I require 2 days autonomy, 3 days autonomy. So that will increase the battery bank size. But once again, I have to make an emphasize here the cost of the system right now. The battery cost is nearly in parity with the panel cost, and rest of the things are fine. So the price of the system is crucial. So it can vary between any 4 hours duration. The price varies between 90 rupees to 140 rupees per watt. Lower the wattage, higher the price. Higher the wattage, lower the price. That's the thing.
Thank you, sir. Another question is, after how much
Yeah.
solar panel get expired? What is the basic lifespan of a
Normally,
solar panel?
the manufacturer gives a lifespan of around 25 years. Actually, it's seen that after 10 years, the degradation of the panel starts. Right from the day one, it starts, but it is very prominent during the 8th year to 10th year. It's around 10% is degraded. That is only 90% the powers are generated. And another 10 years, it comes to around 80% or so. So anything after that, it's 75%. But since in India, we started, there is Indian operation, right for government of India promoted solar energy. It's hardly around 15, 16 years. So we don't have the actual backup how much it's going to come. Maybe in Germany and Japan, they have got a list which normally we follow. The typical life of a solar panel is around 25%. The capacity comes down to 75%. It's 25%, 25 years.
Okay. Then, sir, can be the use of this expired solar panels? Is there any recycling or something like can be done?
No, 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 ma'am. Actually, I'll tell you. Normally, you can see one thing is that in solar power plant, which is used for commercial exploitation, where after 25 years, the capacity comes down to 75, where the ROA will increase, where the investment will be. So at that time, they sell this panel. This can be used for further, like any, you have got more space, less power is required. This you can get it at a very low rate. These panels can be used. Just like in a battery, your battery capacity is 100%. After 5 years, it becomes 50%. It doesn't mean you throw away the battery. It can be given to some other person who can use this 50% for his usage. So likewise, panel can be used. Even after 10 years, you can get the panel, you can use it, but the capacity will come down. If it's a 100-watt panel, it will become 90 watt after 10 years. It will become 80 watt after 20 years. It will come down to 75 watt after 25 years. So even the 75 watt is something like free energy, so you can use that also.
Thanks a lot, sir. Now, another question is related with PWM controller. What is the pulse frequency in the PWM controller? And
Yeah,
if the frequency changes, how do you tackle the change in the amplitude of the pulse with change in frequency?
normally,
Rela-
normally here we use a fixed frequency. Only the width is varied. The frequency is fixed. Normally, typically you can see the filter chokes we have used. Actually, basically that is designed to the frequency of the system. So normally what we do is that to get the maximum efficiency, one thing is that the audible range. So the frequency whatever we use is above hearing. It's around about 20 kilohertz and 22 kilohertz, and you can't go further. If you want to go to 30 kilohertz, 40 kilohertz, the problem is that the switching losses become very prominent. Losses are more, switching losses are more. First of all, you've got the conduction losses there. Apart from that, switching loss will mount up, so they brings down the efficiency of the system. So normally we are seeing to it that annoyance should be less, that is the audible noise should be less. Thereby we go in for a high frequency, that's 22 kilohertz is the optimum where you don't hear the noise, and secondly you get the maximum efficiency possible. But anything above that, it's not possible. And secondly, the conductor size will, what you call this, inductors and all these things size will come down when you use a high frequency. But once again, there's a trade-off, either the cost will increase. But one thing is that at higher frequency, the sizes of the inductor will come down and the package will become more or less. But once again, the efficiency will come down. So the optimum efficiency which one can achieve is around 22 kilowatts. You see any commercial available inverters or any high-end inverters like SMA, CACO, they all go in for this 22 kilowatts. Basically, these are all carrier frequencies. And but the fundamental frequency is going to be 50 hertz only.
Okay. Thank you. Thanks a lot, sir.
Basically, the width depends on the type of voltage you require, the current. Overload condition, the voltage is brought down, or it's basically called as the current fallback. If it has to maintain, because no load condition, you've got around 20% on is there and 80%. Basically, it's a sinusoidal output. And talking about the width, the width varies depending on the area under a sine. So you see in a sine wave at 90 degree, the width is maximum. When you go towards the 0 degree or the 180 degree, the width becomes narrower. So, and this is proportionately varied. The controller sees that about 20% and 20%, all these things are 20% to the particular assigned one. And if the voltage is going to be less due to increase in load, this automatically compensated, and thereby the width is increased to compensate for the loss in due to conduction loss. Then you got the copper loss is there due to transformer.
Yes.
Then switching losses are due to MOSFETs or IGBTs. So these are all taken care of using this control mechanism.
Oh, that's very nice, sir. One more question again related with solar system only, installation of solar system. Is the solar system used in town in area with the inverter batteries, like the inverter batteries which are used generally in the village side or rural areas? Can solar system use along with that?
Yeah, domestic inverters, basically
Yeah.
you have got in towns, they got a domestic inverter where the outages are more than 6 hours or 7 hours a day, where you require a solar system. You can put a simple panel and a small charge control is required, like an on-off charger, low cost one. You can connect it directly to a battery, existing battery. You can connect it without disconnecting the inverter. Let the inverter run as it is. You can directly connect a charge controller to the battery without doing any modification. So this is also available as a package. A small panel, say for instance, you've got all these domestic inverters are all operating at 12 volt only. Only the capacity of the battery varies from 100 Ah to 220 Ah, and the inverter size varies from 500 watt to 1 kilowatt, 2 kilowatt, on and so forth.
Right.
And the panel can determine only one thing is that the panel will only extend certain backup only. Means it can enhance your backup, or it can, suppose you don't get that much charging power, from grid. Your grid availability is only 10 hours, 8 hours per day. So you won't be able to charge the battery fully. At that time, this panel comes in the picture. During daytime, it charges the battery. So this is very useful in very remote areas where grid supply is not stable. It's uncertainty is there now. There's daily.
Yes.
So this is very useful.
Yeah, this is really useful in such areas. Nowadays, we are really facing such problems. Yeah. The another question connected with that, if you can mention where it can be, we can purchase such system, or what is a possible mention procedure to buy such system?
And you have to contact the manufacturers of such systems. That is,
Okay.
inverter
Yeah.
manufacturers, or you can go through this Google search, or you can do.
Hmm.
And it's so many things, so many people are making
Yeah.
this.
Yeah.
Low
There.
cost one, yeah, low cost ones. But if you're going for a high end, that's a different thing. Where only few select companies make high end things, where you got the battery temperatures are monitored, where efficiency is very paramount of importance, but the cost will increase. So once again, you have to see to it that the cost, that is very crucial in this thing. But for any village electrification, on-off charger is also sufficient.
Thank you, sir. In fact, there are so many, two or three questions like that regarding with the cost.
Yeah.
And one more question from very much important from student point of view. What is the kind of a job available in this industry for physics graduates, and what skill they should know?
Ma'am, actually, the people we employ, basically, I had seen that in our company, we have got 3 to 4 people are from physics background only, uh, thanks to Shekhar sir. Uh,
Yeah.
so what we look is that they should have a basic knowledge on electronics. That's very crucial. Means basic fundamental building blocks of electronics is very crucial, and everything should be at the fingertips. Because you have to take quick decisions. You can't rely on books or Google search. Everything should be means snap of a finger. You should know everything. So that's very crucial. And physics background is the one we look out, is that due to the fact that they are exposed to more physical things rather than engineering one, where it's narrowed down to certain particular systems, where you're more emphasis on physics, like electrons, atoms, uh, physical phenomena like temperatures, pressures, volumes. So
Questions.
this all comes.
All.
So in solar field, you can see most of the people are from physics background. Actually,
That's really nice to hear. It's there are some students doing MSc internship also with you.
yeah, 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 yeah. Definitely.
Yeah.
He has done a lot of good job
Yes.
picking up.
Yeah. So one more question, something related with the, can we construct the wall of the building from solar panel?
Yeah, yeah, it can be done. Actually, when panels or manufacturers are available, basically it's used for building purposes. The facade, you can use a
Hmm.
solar panel as a facade. It's just glass enclosure, but only the incident light from the sunlight is, it's not a way, it's a varying one, because
Yeah.
you see that the sun, normally only after a point it can throw light on the panel, and then in the afternoon or in the morning, due to shadow, shadow effect, the panel might be facing in the other direction. The sun rises, or it might be facing the sun. In the evening, it will be the other side down. So you can have the panels on all the sides, but all the panels are not utilized simultaneously. But some power is available during the sunshine period. This extends up to 12 hours. Average sunshine is 5 hours. So this can be used. But once again, the cost is a bit thing, because this has to withstand high pressure, high tension. You're mounting it on a building. So the cost is a big deterrent factor in using system. It is done in Japan and South Korea and Germany, but not that much in our country. So the cost is a very crucial thing.
Thanks. Thanks, sir. One more question from physics background. Do the solar flares have any effect on these panels?
No, it doesn't have much. Solar plant doesn't have much effect on this one.
Yeah.
Yeah, because anyhow, it is filtered already from our atmosphere. The ozone is there. It absorbs all these things. Atmosphere is there, and directly the panels doesn't get up. You see in satellites and all these things, whereas direct solar flares or the directly solar radiation falls on the panel, nothing happens actually. It won't affect our this thing. Whenever electronics are involved, then the problem comes in the picture, because the voltage increases or the current increases. But as such, the panel doesn't get damaged due to this solar flare. But lighting is a very crucial one. That's where the panel failure can occur.
Okay. So more than solar flares, which are far away, we should take care of the storm and lightning.
Lighting is the one, once you see, we have done physics and everything, where more emphasis is on electrons and atoms, where things solar flares can damage the panel, fine. But you see, the day-to-day thing is the lightning, which can occur during every monsoon, which is very much damaging. Uh, that's a main problem for all the panel manufacturers or all the power plant owners. So failures are there always, and it's unavoidable. Maximum protection is required, where costly surge protection devices are used, and lighting arresters are used. But then also it's unpredictable. You can't gauge. It depends on the soil moisture. It depends on the atmospheric moisture. How the lightning is going to strike, no one has got an idea. It's not predictable. So maximum try to protect yourself using all these devices. But failures do occur.
Okay. That many times not in the hand. It's the nature
That's
which
the
comes.
one. Only up to certain extent you can avoid. Just like you've got physicians who can avoid. See, the life expectancy of humans have increased from 50s to now it's 80. Average lifespan of a human being is 73 or 80 for the world. Only some medicines and innovation in medical field this thing has done, but they can't avoid death. Immorality is not there, so there's no way this can also be protected. But maximum whatever is possible, we do it.
Thanks a lot, sir. I think almost all questions are answered. Shekhar, sir, to you.
Yeah, yeah. I think one question is remaining from Mahesh Shetty. Does carbon credit system work in India?
I can't make out.
Yeah.
Why is not clear?
Yeah, yeah. The question is,
Yeah.
am I clear now?
Hello.
Hello?
Yeah.
Yeah. Does carbon credit system work in India?
It was there, but now carbon credit system actually it is not there after the policy change in the government. So earlier it was that uh, you got this carbon credit certificates were available. So normally it used to be exchange or the energy certificates, but now earlier the obligations were there. All these industrial companies should have 7% of their power consumed from solar energy or wind energy, where companies in cities can't generate solar power, so they used to purchase the certificates. And this carbon emission, earlier it was there, you can exchange it from foreign company. Now it is not there, as far as I know. Now it is not there. Earlier it used to be 10 years ago, it used to be there. Carbon credit companies used to purchase it from you. They used to exchange from other country. So that thing was there, but right now it's not there.
Okay. Thank you, Shivkumar. For taking us through the wonderful journey of panel manufacturing, different type of charge controllers, then solar inverters, on-grid, grid-tied, and solar management systems. Thank you very much. And I do remember right after MSc, we had done a project for Motorola.
Yeah, I remember.
When you had enrolled for that.
Yeah.
And we had generated a sine wave using pulse width modulation.
Yeah, using microcontroller.
Yeah, using microcontrollers. I think that was the time when Motorola came out with the first microcontroller in India. And I think we won the second or third prize.
We got the second prize in Asia.
Yeah. Okay, so old days.
They introduced this microcontroller. So there was no flash drive, it was an EEPROM based thing. But we did. But now the world has changed and more compactness and see the memory in a controller now it's far exceeding. Earlier it used to be 1K or 2K. You remember now when we used that microcontroller, it was used to be around 2 KB only. But now you get it in MBs.
Yeah. So I remember we didn't have PCs and we had to
we didn't have
come all that.
Yeah. And we used to use that assembly language and compilers were not there at the time.
Okay. So thank you for the wonderful lecture. Now I would like to propose the oath of thanks. So I begin. I would like to take this opportunity opportunity to thank the Somaya management, the principal, my colleagues in the physics department, especially Amit, More, Ketan Kumar, Pallavi madam. Thank you very much. I would also like to thank all IAPT members for the support, and a special mention. I would like to thank Mahesh Shetty for the discussion and the coordination and all the help in arranging this lecture series. So I would like to thank all our wonderful speakers of this series, starting with Professor Joseph Samuel, Dr. Ahmed, Dr. Atul Modi, Dr. Sri Ganesh Prabhu, Professor Ajit Srivastav, and of course, my friend Mr. Shiv Kumar for their excellent talks. I would like to specially thank Santosh Kundu for all the technical support he has given us. Thank you, everybody, and the wonderful audience. I'd like to thank all of them who were there throughout the series. And now I take this opportunity to announce the third series of lectures to be hosted by Ruparel College. The details of this third series will be posted on different platforms. So please keep tuned in, and thank you very much. And I think his Professor Tyagi was there with us, and Professor Tyagi is the national coordinator for the standard the NACP examination with his one. Yeah, so he is the national coordinator for the NGP examination, and I would like to encourage all students to take this NGP examination, and you do get certificates for this, and there's a direct entry into SNBOS Institute also for the PhD programs. So I thank everybody, and thank you, Shiv Kumar, for agreeing to give this talk. And I know you have a very, very busy schedule.
Right. So right now, ONGC inspection going on.
Yeah.
Time from them. I told them just wait for another. So I'll be meeting them. So this will go on till 8 o'clock or 9 o'clock today.
Yeah, yes.
Much time. Otherwise, I would have been prepared. So
no, it was a talk. Okay. And so thank you very much.
But I would have preferred a whiteboard, explaining all this.
Yeah, surely we would like to call you on campus.
This is a new experience. I'm not type of presentation. It's just stiffening, because I have to sit in a place and do things, explain. Whereas I would like to walk and do things in a whiteboard and explain each and everything with a computer is a different thing, where you provide slides and it's more of a automation or this thing, where you don't feel doing things. But anyway, it's a rich experience which I got from this thing. Anyway, Shekhar for calling me for this program.
Yeah, thank you. So I think we'll end the talk. So time up also. Santosh.
Yes, sir. Yeah.
Yeah, you can end the